Hello, this is checkpoint 5.16 from section 5.3. They want us to use a fundamental theorem of calculus part 1 to find the derivative of this g of r function. So the idea behind this fundamental theorem of calculus of part 1 says that the derivative of an integral of a function evaluated from a to x, the derivative with respect to x of the function, an integral of a function from a to x is going to be the original function f evaluated at the top limit. So this can actually sit as another derivative formula, just like the derivative of x to the nth power is n times x to the n minus 1, and the sum and difference and the quotient rule and the chain rule and the product rules, those are all formulas for derivatives, and here is yet another formula that we can add on to our derivative list. And so if we take a look at the problem that's given, g of r is equal to the integral from 0 to r of this function, the square root of x squared plus 4 dx. Now it's saying the exact same thing, except they have the variables in different places. So let's first talk about the variable within the integral, and that variable is sometimes called a dummy variable. And so that variable, essentially with a definite integral, the variable really just disappears because you're going to integrate this with respect to t and get a function, the antiderivative, and then you're going to evaluate this from a to x. And so you're going to get a function of x eventually. When you take the derivative of that, the derivative of f of a is going to be 0 because that's a constant. And then now the derivative of the integral is just going to give you the original function. So this x is just a dummy variable. The real variable that we're dealing with here is x. So x is your real variable, and so here in this case the real variable that you're dealing with is r. So when we're taking the derivative of this, we can say we can dr of g of r, or we can just say g prime of r. That's the same thing. And if we take the derivative of the right hand side, we can say ddr of this integral from 0 to r of this function, x squared plus 4 dx. Now, because this is a dummy variable, we can replace this with anything. We can replace it with t, or whatever letter we want. But the whole idea is that by taking advantage of this formula, this whole thing here is we just want to focus on this function, the square root of x squared plus 4, except we're going to replace it with r. So here, this is going to be g prime of r is equal to the square root of r squared plus 4. And remember, it gets replaced with r because after you do this antiderivative, you're going to get that original variable back. All right, so this is it. This is your answer. Hope that helps.